Hello everyone. Today we'll be talking about the domains of functions. First, the definition. A domain of a function is a set of all inputs in an expression that is defined as a real value. If we think in the real world sense, we can look at the type of currency that's allowed at a soda pop machine. Now, not every single piece of currency can work, so let's ask ourselves, what types of currency can we put into a pop machine? Here we have a bunch of different currencies and of course a pop machine, and we can look to say, alright, well, which ones actually will work? We can see that the ones that are accepted would be the green circles, and the ones with the X's are not accepted. Therefore, we can say that in the domain, what can be put into the pop machine is going to be dollar bills, quarters, nickels, dimes, and in recent years, credit cards. That means things that are not in the domain are going to be your $20 bills or higher, pennies, and foreign currency. Which, by the way, I found a penny earlier. I can't use it to get a pop. Darn. Now let's look more at a discrete example. Discrete means that it's particular values and particular points. So let's say we're given a function, g, that's defined as g of 5 is 7, g of negative 1 is 11, and g of 2.6 is 12. Let's look at the domain of the function g. So we need to ask ourselves, what is allowed to be put into the function g? Luckily, they give you those values. If we look at each individual case, we can highlight the input. 5 in the first case, negative 1 in the second case, and 2.6 in the third case. Therefore, the input of g is the set negative 1, 2.6, and 5. By the definition of domain, the domain of g then would have to be the set negative 1, 2.6, and 5. These are the only values that are defined in the given function. Thus, those are the only values that are in the domain. Now, we usually look at functions that have more than just particular points in the domain. In fact, we could look at an interval. Let's look at the function f of x equals 1 over 3x minus 5. Let's find the domain. Now, unlike the last problem, we can't just pick numbers. Well, we could, but it's going to take us forever to figure out which ones actually work. So let's ask ourselves another question. What are all the values of x that will make the function undefined? This is easier to find than finding all the numbers that will work in the function. Now, since the variable is in the domain or denominator, the function f has the possibility to become division by 0, which is undefined. So we need to find the value that will make this denominator 0. So let's set up an equation. 3x minus 5 cannot equal 0, and let's solve for that. We'll find that x cannot equal 5 divided by 3. This is the only value that is not allowed in f of x. Therefore, the domain is everything else. Written in interval notation, the domain of f equals the first interval, negative infinity to 5/3, union 5/3 to positive infinity. And again, this is your interval notation. This is something you should remember from 105. Let's look at another example, something that looks a little bit different than having rational. Let's find the domain of h. This time, h is equal to 2 times the square root of the quantity 4x plus 22. Again, we're going to ask ourselves, let's look at the values that are not allowed, and then everything else will be in the domain. So what are the values of x that will make the function undefined? This time we have a square root. Now remember, you can't take the square root of a negative number. So since the variable is in the radicand for an even root, it is possible for the radicand to be less than 0. But we can't take the square root of a negative number. So we need to make sure that the radicand is always non-negative, which means 0 or positive, because the root and index is even. So let's set up the inequality. 4x plus 22 is greater than or equal to 0. I'm using 4x plus 22 because that's the radicand. If we solve this inequality, we get x must be greater than or equal to negative 11 over 2. We use this as our, so then that shows you what x must be. So the domain of h then is going to be the interval negative 11 over 2 all the way to infinity. Notice that for negative 11 over 22, I have a bracket that shows that we are including the endpoint. That is because we're using the notation of greater than or equal to. And that's it for this video. We'll see you again next time when we talk about, well, more math.